Today's video will discuss Chapter 8.5, Constant Rate of Change and Direct Variation. So the first thing to start with is a constant rate of change. So the idea is, what does that look like? And so I want to talk about three different rates of change. This first one, you'll notice, is a straight line, and it's going up if you're reading from left to right. And so that is a positive rate of change as it moves up left to right. Negative rate of change moves down as I'm going from left to right. And so keep in mind, obviously, if I were to read this one right to left, you could say this one's going down, which is why it's really important as you read the English language, you also read this graph. It's going from left to right. So this is positive, and this one's negative. Notice both of these are straight lines. This one, well, it does look like if I'm reading from left to right that it's going up. It is not going up by a straight line, right? You'll notice the curve. So this is not a constant rate of change. There may be a positive change. So the difference between, say, this point on y, so like maybe up here and here, this point's higher, right? It's larger. It's positive in terms of the change. It is not a constant rate of change. It's not going up at a constant rate. And so that's really important to understand. That must be a straight line, and so you've got positive, negative, and then not a constant rate of change. I want to start with an example problem for the textbook. And so I'm looking at this graph up here. You can see that. I'm going to try to get the camera a little closer. And so I'm looking at the two circles, and they're talking about the radius of the circle compared to the number of seconds. So the circles are obviously changing in terms of size. And there are a couple things I want to talk about. So notice the points on the graph, right? And then also notice where it is that they intersect. And move the camera away for a moment. So if you're looking at these points, I'm going to keep in mind these points and these points. We're going to start with circle 1. We're going to find the rate of change for circle 1. Notice that it is a straight line, which means it's constant. It also is going down as I read left to right, so this is a negative rate of change. This rate of change is going up. It is also a straight line, so this is a positive rate of change. So the green line is negative. The blue line is positive. I want to focus for just one quick second on where it is that they intersect. And so if you think about it, this is the radius of circle 1. This is the radius of circle 2. You'll notice circle 2 at the beginning is starting at 0, which means it didn't exist. It is then getting larger and larger and larger, and then at that point, they're actually the exact same size. So circle 1 and circle 2 would be overlapping each other, and then they would kind of move past. Okay, but let's take a look for a moment. That's just a concept of reading the graph. I want to take a moment and come back to rate of change for a moment. Looking at circle 1 and then circle 2. So I'm going to take this point, and this point, and then this point, and this point. So if we look at that, let me readjust the camera. If I look at that on a slide, circle 1, I'm taking that first point, which was 4, 6, and the second point, which was 5, 2. So if you look at that, coming back, you can obviously rewind in the video, but I'm looking at this point, 6, 4. I'm just going with y first. So it's 6, 4, and then I'm looking at this point, which is 2, 5. Now keep in mind, I apologize for saying that wrong, this is y, so it's x, y, x, y. Notice that the 6, it was 6 comma 4, and so I don't then move it so it's 5 minus 4, 6 minus 2 to try to keep it positive, because 6 and 4 are married, 2 and 5 are married. All right, so this radius is 4 minus 5 is negative 1. 6 minus 2 is 4. So this is going at negative 1/4 on what is it that we were talking about? Centimeters per second. Okay, so this circle was shrinking at a rate of negative 1/4 centimeters per second. Now if you take a look at circle 2, which is here, remember now I'm going to use this point first, so this is 4, 6, and this is 2, 3. So I'm looking at the blue line, and notice that I picked the point to the left first both times, so I picked the further left point, that's going to help me keep the x positive. So I'm looking at 4, 6, and 2, 3. 6 minus 3 is 3. 4 minus 2 is 2. So this is positive. You could write it as 1.5, but I'm going to write it as 3/2 centimeters. That is not a good looking M. Centimeters per second. Okay, so circle 1 is shrinking at a rate of -1/4 centimeters per second. Circle 2 is increasing at a rate of 3/2 centimeters per second, or 1.5 centimeters per second. The next concept I want to focus on is direct variation. So direct variation is something that looks like this. It's a straight line. It goes through the origin, which is at 0, 0, and it can be written in the equation of y equals kx, with k being a constant. So it's just a constant rate. So k is a number, 2, 3, 7. Of course, it could be going down, -4, -8. Okay, but keep in mind, it could even be a fraction, 3/2, 5/6. Okay, k is the constant, it's the rate of change, the constant rate of change, and then x and y are just points on this line. Right, so like this is x comma y, x comma y, x comma y. And so each of these would give you the x and the y, and then the k is our value. So if we're looking at something like this, and if this tells us that it varies directly, it means that this is a direct variation, so I now know that I can write this in the form of y equals kx. But your problem is you don't necessarily know right now what k is. However, I do know x and I do know y. So I can choose any of these numbers and substitute them in. So I'm going to intentionally pick this number and this number because I want to show you that it works two different ways. So the first way, let's pick the 10 and the 40. I'm going to substitute 40 in for y, and I don't know what k is, but I'm going to substitute 10 in for x. And so I now have 40 equals 10k. Let's switch colors for a sec. I'm then going to divide by 10, and I've got k equals 4. Okay, that'd be one way to solve it. Another way would be to use the other point, which was 2.5 and 10. So I would say 10 equals k times 2.5. So this is 10 equals 2.5k. I'm then going to divide both sides by 2.5. And k equals 4. So what you notice is that either way, I get myself to k equals 4. So as I come back to the first, now I know the formula. Because I know that as long as I take x and I multiply it by 4, this is the formula for anything along here. And if I wanted to, right, I could go 25 times 4 equals 100. 3.75 times 4 equals 15. I could take any number I want, figure out, substitute in for x, figure out what y is. So as you get this table, what I'm trying to do is figure out, okay, what is the equation, right? What is the formula, or if you want to call it that, it's really the equation to determine this variation, direct variation. All right, that's all we got for you on constant rate of change and direct variation. Thanks very much for watching the video. Don't forget to do the problems at the bottom of the page. I'll see you in class.